Show of hands. Okay, well, welcome. And in case you're wondering, this is something we do every Saturday. So this is not a new occurrence. We keep switching over topics. It's not machine learning or data science every Saturday. We do a lot of different things. Like, for example, next week we'll be working with Arduino. The week after that, we might be working with software. We try to concentrate on exponential tech, so that has a lot of different definitions. So there are many different things. But this session is part of, I'll just explain to you what are different stuff before I hand it over to Ricardo. Just a little bit about the assembly. We've been based out of this before it was in this location for the last 5 years. Infive was the startup incubator. It was one of the villas there before. We were there as well. Then we moved with them. We've done over 250 free workshops. That number keeps increasing because we do one every week. So it's a very packed schedule, and we announce the calendar. Most of you have signed up. We do kind of insist on signing up there because we want to make sure that everyone is informed about all the activities that we do, plus so that we can manage resources and make sure that there is. So we do a few different streams of workshops. There's the assembly hack workshops where we work with hardware, embedded systems, things like Arduinos, Raspberry Pis. It could also be like augmented reality, IoT. There are many different categories in that. You don't have to bring your own hardware. We provide it. So all the sensors. We'll be doing a few IoT workshops later on in February, including one with Etisalat. And we'll be providing all the edge devices and everything. You just have to bring your laptop and we'll guide you. All our workshops are entirely free. We believe in keeping this sharing of knowledge completely free. So we aim for collaboration. The other stream we have is assembly code, where we don't use so much hardware, but we work with APIs, frameworks. Previously, data science came under assembly code, but we recently launched a new assembly data science stream. This is actually only the second workshop that we've done. The first we did back in December, and we were doing it on OpenCV and computer vision and how it relates to machine learning. Data science is going to be more advanced topics, and we will try to keep specialists like Ricardo, like our first speaker, so that we can present you some more premium content. So people who have a little bit of understanding of data science, we're going to try to keep it accessible so that within 3 hours you can get some knowledge, but we try to keep it a little bit more advanced. So that's why we always say you should have a little bit of understanding of the basics. So it's not like you have to be a machine learning expert or a data science expert, but it would help. Our target audience goes across the board. So we don't only target entrepreneurs because we're in the entrepreneurship hub, but also working professionals and students from colleges. It's usually 15 and above because the material we give is a little bit more advanced. We focus on practical applications as well. So practical applications mean our workshops are not going to always be just learn 101 and take down theory. There will be some interactive component and there will be some practical thing. We want you to go away from this feeling like you built something and that you've learned something. You all signed up for our forum outside, so you will have the details on there about the other workshops. We will post content also. We are also live streaming this on YouTube today. So the data science workshops we're live streaming on YouTube as well. So if you want to go and check it out after the fact, you can see that the whole presentation will be on there. We're very active on social media. You can find us as Make Smart Things rather than the assembly, because that's our mission statement. We're on Facebook, Twitter, Instagram. We post at least 2 videos every week, preview workshops, and of course like recaps of this. But we're also on LinkedIn. I think this just needs to be updated. So please do link with us. Do tag yourself. There's a lot of content on there. We do want people to reach out not just to us but to each other, so that we can make a proper technology skills community based out of right here. So just before I hand it over to Ricardo, I just wanted to first of all say thank you to him. He is traveling in a little while, in a few days, but he has agreed very kindly. Ricardo is a machine learning expert. If you search for him on Google, you will find all his Medium articles towards data science. GitHub, of course, which he's going to share here as well. So he's a hardcore machine learning expert, but he's also somebody who's worked practically with that. Not just in what he does. He works at Property Finder right now. In that case, he works with machine learning in a practical capacity, but he's also done a lot of research on things like retinopathy, things that you want machine learning to solve. So Ricardo has done a lot of research on that. So apart from the work he does professionally, he does a lot of research for his own sake, and he will actually give you a bit more info on that. So I'm just going to hand it over to Ricardo. Are you going to be on that side? I'll just switch off the mic. You're hooked up with that. I'll switch over to your presentation as well.
Thank you so much. Thank you everybody for coming. I appreciate it. I'm going to be a little bit nervous because you're a lot of people, so be kind. The purpose of this presentation mostly is to give an introduction of what I've been researching in the last 2 years. But I think the value out of this is how to take an idea and put it into production, release it. In my experience, I've been working as data scientist for 4 or 5 years and as a researcher for 2, 3 years. And taking an idea and see it like in a web page or some kind of final application is quite hard. And it's not because the solutions are not great, it's because there's a lot of factors that affect this, like politics, like business, like value. How do we create an idea that in the end creates money to the company? Otherwise, they are not going to invest in you. So that's why I got the idea of giving this presentation. So in this workshop, I am not the one who's going to work. It's going to be you. And I'm going to watch you. It is created in a way that we will gather in teams, and then these teams are going to collaborate to solve certain activities. We're going to tackle the machine learning cycle. Normally, we go straight to coding or to solving an idea without even thinking. So in this case, we're going to try to create a solution that is good for us and it's going to be good for the business. But let's start with something controversial. Why machine learning projects fail? This is actually an example for software engineers, but business is always like, okay, I want to create money with this. And then engineers are like, no, that's not fun, that's too simple. I want to create something super complex and then we figure out how do we sell it. So normally, when an engineer says, this is not gonna work, it's actually like a big success. Like, I don't know, what is an application that surprised everybody because of its simplicity. Normally, simple applications are very successful. And then, when an engineer says, this is super exciting, I already have one, actually it fails. Because it's too complex, nobody understands it. So we need to come to a midpoint where business and engineers are happy with it, and I think that's going to be the way to create something very successful. So, who's data scientist here? Raise your hand. That's great. That's why we're here, right? Who's been involved on a machine learning project lately? Or someone? Good. So now you're going to have to believe me when I say this. But when a machine learning project fails, it's because most of the time there's not a clear understanding on what the business wants. So normally you will have different kind of bosses. You will have the boss that doesn't know anything about machine learning, but they know it's a miracle. So it's like, I want you to solve this in 2 weeks, and I want it to be perfect. Then you check the program, and it's like, it's always like that. Yeah, exactly. You see the problem, and it's like, okay, you want me to build Facebook in 2 weeks, and then you want it to be perfect. Okay, I'm gonna do my best. I don't want you to fire me, so I'm gonna say yes. And I'm gonna work as hard as I can, and then after 2 weeks, I'm gonna say, what is the progress? And then you can say, okay, I just configure my virtual environment and run Python. That's pretty much it. Another problem is you will find, it's sad to say, you will find people that say they're experts, and then when they're in the company, they give no solutions, but as the technical terms of machine learning are too complex to understand for business people, they believe and believe and believe, and there's no results. So this is very common. If there is not talent in the company, you need to have a pyramid. You need to have a specialist, and then you can have some juniors, And all together, we'll create a solution, and then the junior are going to turn senior, and etc. So there needs to be a specific amount of talent in the company to solve this problem. Across the company, not just the data science team. You need a managing team that is at least is aware on how this works, a software engineering team that knows how it works, and they need to be prepared to go from the start to the end. There are several teams that are involved, like DevOps. They need to know how to deploy these kind of things. UX, they need to know how to present the solutions to people, and people need to understand what we're trying to sell, and these kind of relationships. As I said, expectations from business are too high and sometimes unachievable. So when I arrived to a company, let's say X, they told me, I need you to solve this. And they wanted a very complex pipeline, and they want also the engineering performance to be high. And then I was working for 2 weeks. They got like nervous. Like, this guy, I think, is not gonna finish. And then the project manager sat down with me. It's like, okay, let's project manage this. How long is it gonna take? 1 month? Probably like 1 year actually. And then they were super surprised. It's like, how come you are an expert? Like, yeah, that's what people say, but this is actually not solvable in 1 month. There's another one. The required data, they don't have data. Or if they want to get it, it's super expensive. That also happens. Also, we get excited and we create the most complex solution. Like, yeah, this is like 15 ensemble models, and then more models, and then in the end, you get a 99.99% accuracy or F1 or whatever. And then, okay, it's like, engineers, now this is your problem. And then the engineers start scratching their heads. It's like, first of all, this is Python. I don't know what is this. Second of all, you wrote 10,000 lines of code, which is an spaghetti. And then engineers go to complain to business or to the manager, like, I cannot work with this. It's impossible to understand. And then reject it. And then the manager of the data scientist complains to business and say, hey, the data engineers are not helping. That's why I cannot deploy my solutions. And then it's just ping, ping, and nothing happens. So then you have another thing, also with complex solutions. So you create something super complex, but business needs to approve. Let's say a scoring model or a pricing model. So you create the most complex machine learning model to define the price of a car insurance. One car. And then they reject it because they say, I need the client to understand how am I calculating this price. Otherwise, they won't trust me and they are not going to buy it. So another case of complexity. How does this work? No? So too complex, no? What can I do? Just give up. Thank you very much, that's it. I hope you enjoyed the presentation. No. Let's see some real situations. These are from my experience, and there are more, but I'm going to give you a few. So this is classic. This is a classic. Actually, this is a common factor on all the companies I work. They come to you and they're like, I want to solve this problem with machine learning. Great. Okay. Let's talk. Let's understand the problem. And then you come to the point where you ask for data. And they're like, data? I don't have data. Okay, so how do you want to solve this problem with machine learning without data? No, I don't know. You tell me. That's why I hired you. Like, so that's actually a good answer. Huh? So then the problem is with you again. So you need to get creative. So here are several things you can do. You can crawl data from a website. If it's a competition, even better. You can transfer learning from public domain data, a data set that is public, and create a smaller private, and then transfer learning. Or, I mean, machine learning is not everything, right? There are other mathematical tools that you can use, like linear programming. So in the end, it's optimization. If you have a small data set or knowledge, you can create an optimization design. And maybe you will have a lot of assumptions, but it's going to be great just to start. Once you start, you can start gathering data from people, and now you can create something more complex. Also a classic. And also across all my companies. The project is managed as a software development one. This is classic because it's like, okay, we're gonna be agile and we will have sprints, and every sprint will have 2 weeks. And every 2 weeks you need to give me a delivery and advance. And then they don't understand the data science or machine learning cycle. They don't understand that to start having results, you need to first understand the data, then gather the data, and then train the models. But they want the model to be from day one. Like, how can you fix this? Okay. First, and you will hear it across several conversations. In companies that are in early stages of data science or machine learning, you need to teach them. You need to educate the stakeholders. You need to help them understand that the development cycle is not like to software engineering, but to research and development, which is quite different. You need to make them understand also that machine learning is not deterministic. You can have different outcomes, and it depends a lot on the data. Once they understand that, they might help you. So now, you try to explain them, they didn't understand, but they still want the results next week. So they do some numbers and like, okay, the team is costing X amount of money, and I am losing time. So I'm gonna define the project as low priority. And then, as you need a lot of help from other teams, and as your project is low priority, they're not gonna help you. So you're alone. And your project never sees light. So this is something I tried and it actually worked. So when the business doesn't believe in you, the only person that can believe in you is you. So try to convince other people that is motivated to create a POC, a proof of concept. Show it to business, and then they get excited again. And like, okay, it works, take some more money. And then you can pitch it to the right people. This is another classic one. I am laughing because I am remembering all the stories and all the people. So you will come to a meeting, and the guy, this very tech-savvy guy, is going to tell you, yeah, I want you to use convolution neural networks, recursive neural networks, and deep learning, and AI, and all the words that you can imagine to solve this problem. Okay, what's the problem? I want you to give me the number of people that is buying our product. But that's just SQL. No, but I want it to be machine learning. Okay. So the advice here is Even if the stakeholders are too interested on machine learning, try to understand the problem and try to solve it with the right tools. Otherwise, it's gonna cost a lot of money in the company, and in the long run, they're gonna lose trust. So you don't want that. And another thing you can do is, most of the problems are already solved. So maybe you can try to look for some cases, see how they solve the problem, and try to replicate. That also works. So today we're gonna try to learn with a real case. I didn't want to use my company's examples, just because. So we're gonna see this picture. What parts of this picture do you think you can use machine learning? Come on. Anyone? Sorry? I can. Like, where? Yes. Here? Yeah. The advertisement, right? What kind of solutions you can create there? So let's imagine what happens if you show the same listings to all the people. The exact tree. 1, 2, 3. Let's say my budget is very low, and you show me very expensive properties. What happens? I'm not gonna click it, right? But let's say I'm very rich, and you show me very cheap properties. I'm not gonna click it. Let's say I don't even want properties. I'm not gonna click it. So one problem is, how do you customize the content or the advertisement you are showing to be a specific guy or gal? That's one problem. Another one, from a company I work. Let's say you created an algorithm and it shows 3 specific listings that are customized to one client. But then the quality of the pictures is super low, and then one of the pictures has a bathroom, and then another picture has a guy. Like, you got your super smart algorithm, and then you're showing low content quality, low quality content. That's another thing you can do. Well, there are other kind of things you can do, like click rate prediction, and I don't know what else. There's another advertisement right there, so maybe you can put that there and that one here. I don't know. But as some of you already know, I've been working with images, and also with text, mostly with images. And I focus on a problem. Actually, you were right, this is that one. I am focusing on a problem to generalize. You would see that when, for example, when you go to the visual, you create a listing, and it's not published right away. There is maybe an algorithm, maybe people, most of the time people, that analyze that the images are right, the content is right, and after that, after they validate, they publish. So this is a big problem across several industries, so mostly web pages. And I wanted to focus on that, because you can apply it to several things. So as I described this before, the company has an algorithm that, given a user, is going to show the perfect content to that person. But in order to show that, it not only has to be the perfect property, but it also have to be something nice, so they are engaged and they click it. In some cases, you will have that listings. We have, even if it's a car, it's a computer or a property, you will have several pictures, right? And you don't know which picture is the one that is gonna make the user click it. For example, if you go to Netflix, they don't only personalize the content, they also have an algorithm to show you the exact picture so you click it. That's actually quite cool. So depending on the person, it's going to show, I don't know, the movie, and then the picture of the movie that actually is going to make the user click it. So the question is, what can we do to create a score and not only rank the content, but also the quality of the content? Before going to code, this is what that I will try to show you today, how it works. And normally, if you follow this process, the probability to succeed is much higher. So you will have that in the beginning, you need to make sure that all the team understands what they have to do. And you need to make sure that the business have proper expectations of what can you do. Then, okay, I know what I have to do. I go to our databases and see if we have the data to do it. If I have the data to do it, I try to clean it, remove outliers, handle missing values, and other kind of stuff. Basically cleaning the data set. And if I full clean the data set, I can create a model, a first model. In the beginning, it's good not to create something simple. But if you go right away to the complex one and you succeed, that's great. Then you will have the evaluation. And again, the model with best F1 score or recall or sensitivity, whatever, is not the one that is going to create the most value to the company. So in the evaluation part, you need to create metrics for business and metrics for the model. And in deployment, you need to make sure that when you arrive here, the code is as good as possible. So engineering just deploy it and create all the dependencies around it. You need to avoid the situation where you give them the code and then they don't know what to do with it and then they give it back. As you can see, there is not a line here or from here to here. So it's a nice idea just to have something that is just working. But you will have that after modeling, you will go back, prepare the data, maybe add some more columns, features, find more data sets, and after understanding the problem, you can go to the data understanding. Maybe you figure out that you don't have the data, you go back to business and say, okay, I need to buy this data set, or we need to get the data from here and it's going to take more time. And once we are set, you can continue to data preparation. Any question up to here? No? Not good. You believe me? Nice. So first, let's go to business understanding. In business understanding, you need to know exactly what you need to do and exactly what business is expecting. So you need to go to business and tell them what is the question you want to answer. I don't want the solution. I want the question. What are the hypotheses? I want you to tell me what do you expect from this solution. And you can analyze together, and with your experience, you can say, no, I don't think it's going to happen, but it's going to take this time. And you can also say, I think it's very easy, let's just do it. And while you're advising in the machine learning cycle, you can also pivot, because businesses change quite fast, and so you have to change your solutions. So you need to go the same way as the business, because if the business moves towards another way, your problem is, your solution is going to be deprecated. Something also nice to have is you have to break the problem into subtasks. But an advice I give you is, you as data scientist or machine learning engineer or whatever branch we're working on, you need to make sure that these subtasks maintain the stakeholders engaged. Because you can create, it's not linear, right? If you first take the data set, clean it, all these tasks are not gonna create any delivery. It's not like, yeah, you go to the manager and say, okay, I already cleaned the data set after 2 weeks. They're gonna say, okay, I want to see something. I can show you the data set. No, I don't want to see the data, I want to see something working. So this is something that has worked for me before, is always iterate in a way that you can show something. And also something that has worked with me is, if you can invest a little bit of time to create an application, like something with front end and nice pictures and maybe dynamic things, that is going to engage them even more. And you can show progress constantly. So we'll have our first activity. I gave you the problem statement. I need you to gather in teams, but how can we do it? Maybe by lines? Do you think is proper? Okay. So every line is going to be a team. You're going to discuss the problem statements. Make sure that everybody in the team understands what they need to do. Define some hypotheses and break the problem into subtasks. And you have 50 minutes, right? Or do you need more or less? You don't know, that's the right question. Great. So let's go over it, and after we finish, we can discuss. I'm going to be available all the time, so you can ask me questions. I am going to play as business. Yay! You can ask me anything. Someone who was not paying attention. Great.
Or bigger groups, maybe. If you want to do it, I mean, we can organize everyone from this. Yeah, everyone's organizing groups, right? So we got an activity going on. So are you guys organizing the teams or do you want us to assign them? Everyone's done?
You're already working, right?
You folks came in, so
So, quick question before. So you know what you need to do. Define hypothesis and break the problem into subtasks. Okay? I'm gonna turn back to the problem statement.
Not necessarily because to solve it, you already know what's going on. So before you solve it, you say, for example, if I improve the content of the pictures, the people will click more often. And you can even do it. You will click 15% more. And it's just an idea. You will, after you solve it, you will figure it out.
Okay, thanks a lot. Please come back to your seats. Ah, a lot of excited people. That's good. So as business, I'm a little bit concerned because some teams didn't get what they need to do. So maybe my investment is not going to have good returns. But in the end, after we discussed, I saw a better understanding of the problem. Now I want to see with not random. I'm not gonna pick randomly. I'm just gonna. It's gonna be voluntarily now. Who wants to tell me what's the hypothesis and some of the subtasks we're gonna create? Raise your hand. This is what I expected. Nice. Okay. Do we have a microphone so we can hear you? I think there was one here. Maybe not. Can we get a mic? A mic so they can understand it? They can turn on. So this is actually a conversation. I don't want to be speaking alone. They're gonna bring a microphone, but before, I want to re-explain what I wanted as business. So as I said, some very smart people created an algorithm that runs all my content and shows the top three given a user. So let's say I want an apartment in Dubai Marina with rent of 50,000. So they show it. All the apartments in Dubai Marina that are 50,000 rent. The location, maybe the tower, they improve it too. But then in the end, they just show it without taking a look at it. No? And after they show it, there is in the first picture, you have a guy saying hi. Haven't you seen this? There's two guys like, and no property. And then the second picture is, I don't know, a car. I don't want to see the car, I want to see the apartment. And maybe the third one is pixelated. So you cannot even see anything. So that's another problem, right? We have two machine learning problems. We already solved one. Now another one arises. I want to solve the second problem. So who got it right in the end? So disappointed. We lost 1 month of work. No, I'm kidding. I'm just waiting for the microphone. They went to buy a microphone to Mall of the Emirates. So let's wait.
Let's pick someone with loud voice.
Someone with loud voice. Okay.
So As you said, we discussed that again, thank you for really good idea and speaking of my. But yeah, so it's a really given problem, we think, that we need to classify the images with whatever is in that image. So if it's a bat, for example, a master bedroom, or if it's an arm, or if it's whatever. And if you can't tell from, if our algorithm cannot classify that if it's a bad quality image, maybe the pixel resolution is not good enough for us to be able to classify. So we think it's an image classification problem, and we should rank. So we classify the images as maybe yeah, when they're classified, then we can match the classification related to whatever the input match.
That's actually a great example. And you created another problem, which is great, no? I like solving problems. So he said, okay, I want to classify the pictures, and there are different ways to classify a picture. You can classify the content of the picture, you can classify the overall picture, right? But then he said, but what happens if the image is low quality? Then I cannot classify anything. So I'm assuming that if I cannot classify, then it's a low quality picture, which might not be right? So why not we step back? Why don't we first see if the quality of all the pixels together have turned into a good quality picture, and then I analyze the content. Sounds good, no? Now we have two problems. This is called subtask. So I took the bigger problem and I divided it into two. So we have two subtasks now. Great. So someone else raise the hand. Okay.
We can define parameter for each. So we can define the quality as restriction for the user. Like user cannot go to the picture things not meeting this quality. Then after that you can take the misclassified pictures and again.
Okay. So here he created another problem. So he said, I already have my algorithm that creates a score for each image, but I'm going to put the filter in the beginning. It's like, I'm not going to allow you to upload bad quality images. So you solve the problem from the beginning, but you create another problem. How do you pick the right score? Like, you have a score from 0 to 1. Which one is bad quality? Which one is good quality? That's another subtask. That's great. We have 3 now. But nobody has mentioned the hypothesis.
Okay.
Great. So, did someone turn with a good hypothesis of what happens if you select or classify good or bad quality images? No? Okay. Here we have a volunteer. Brave volunteer.
We were just discussing at the end, understanding for the business what are the KPIs which is required from that. So irrespective of how good or bad, what is the actual succession rate in terms of clicks and actually closure of the business of the booking. So what is the business expecting that? Then we can measure whether the quality of the picture or of those information which is displayed is successful. We think.
Great. So the hypothesis is if the quality, the content has good quality, the number of clicks is going to increase. So you will have, and in the industry we call it leads. So if the content of the listing is high, then we will have more leads. And this is related to this subtask. So if I promise the user, if you create good quality content, you will have more leads, which turns into a higher probability of selling the property or renting the property, which turns into profit. Now they like it. So we have a hypothesis, that's great. And in the end, people were asking, what's a hypothesis? It's something that you expect. It's like trying to, you define a sentence in which you say, doing this, doing X, I'm gonna get Y. So increasing the quality score by 20%,
it's gonna turn into a 15% more clicks or more leads. That's a hypothesis. And once we define the hypothesis, and if you explain this to the business, we're speaking the same terms, no? We're saying, okay, I want to create a black box that if it's successful, I'm going to get you 50% or 15 or 20% more leads. They're going to say, money, perfect. So everybody's on the same page now? Great. Any other opinion? I don't want to. Yes?
Probably if you use at the very beginning, at the filtration stage, if you use technologies like OpenCV or image recognition, you will be able to identify the fields of this image and what is the quality level of it automatically. So you don't trust the customer only one source. You trust also the OpenCV library.
And that's true, but for a different part of the iteration. If you go straight to that right now, you might lose the business and they might get excited. Like, yes, OpenCV, machine learning, classification, whatever, hype. But then they will expect more and more and more and more. And when you have the solution, boom. It's like, but your solution just increased the content, the clicks by 1%. And I invested 6 months of work on your solution. So it's better if we, in the beginning, define everything without any solution, like technical solution. But we create like a statement that they are happy with, we are happy with, and we expect to fulfill. And then we are happy, we can continue, right? But it's a great idea for the next part of the challenge. So now we have data understanding. So let's say, these are the questions. Do we have the data? Do we have the data right now? No. Is it expensive to get it? What do you think? Could be. Okay. We don't know. We need to figure out. And the other question is, can we trust the data? So this is, from my experience, this is a very common one. I can give you an example. Let's go to the car insurance. So when I was working for the company that was selling insurance for cars, they got a data set that comes from the regulator. And the regulator, the way they define or the way they store the claims, they call it, which is how expensive was the crash, was not specifically to calculate the pricing. The purpose was another one. It was actually for taxes and this kind of stuff. So the dates are different, are shifted. So you actually want, for example, let's say, the crash happened in 2000, and then for tax purposes and all these things, it was registered 6 months after. So it's 6 months. So actually, the claims by then might be much higher, and you are charging much less. So the purpose of the data is different, so it's not actually useful. So you need to analyze what's the purpose, and if you can fix it. If you can't fix it, then you might you should find another way to get the data. Any question? So the problem is we don't have data. What do we do? Okay. Good thing is in machine learning, computer science, actually in computer science, we are a very friendly community. We like to share, and we are very competitive too, which is nice. So you will find that for a lot of applications, you will have benchmarks where people test their algorithms and try to rank against other people. There's always Google fighting against Facebook and ABM, like IBM, like I want to be with you guys. And then HP trying not to die. So actually there is one step before. You should find this data set and and then try to understand it. In this case, because of the limited amount of time, I am giving you the data set. So I will need you to download this and first examine it. Secondly, what are the attributes? What are the X? Then what is the target? What is the Y? And make sure that everybody in your team understands the data set and how to use it. Okay? For this, we will have 25 minutes, so we have 5 minutes discussion. 20 minutes just to write this. If you look for live data set, you can find it in Google, on Google. Now you're feeling all the pain of the data science.
I'm gonna solve this problem. Yes, I am gonna share it with this. That's what I was gonna do. No. Minutes. 3 minutes.
Yes, and that's 6 hours. Maybe we crashed the network. I just want them to struggle because that's life. they download it, yes. It is fine. No, it's okay.
One question. Who has the file already? You have the file and you got the password? Almost. You have 16 minutes left. Huh? I mean, 16 minutes left for the activity, yeah.
Yeah, just leave it here and then we get it. No, it's objective score. It's called objective score. So it means I'm going to show you an image. What the quality of this image. You see 3, 4, 7. And then I take the average of your opinion. Objective score is okay. And then you have STD, standard deviation. Yes, it's the average. I think they modified something in the experiment and they aligned the. And that's the. Yes. And the demons is there. Why? The why. What the X? No, what's the X? The X is the. In all of them. As part of the team. Okay, I have some people with the data. Who's missing? Also, the rest of the people already have it. Okay. So the question now is, do you understand the data set? Great. I have used this with the data set. Who wants it?
Want to talk for it, no? Okay, I want to explain something. The people that came for the data set with me, I gave them something that the people downloaded doesn't have. So you will see. You have 7 minutes. You already have it, no? Okay, time's up. Quick survey. In the end, who got the data? So I lost half of the group. Who could open all the files? So I lost 1/4 of the group. Okay. So let's discuss what problems did you have? What was the first problem you had? One at a time. Downloading the files, right? It was 600 megabytes.
and then we crashed the network, and nobody complained. I'm surprised. Okay. Then some people came to me, stole the file from me, and I think the first were you. And then the people that downloaded the file and managed to get the password saw that there was a file with extension .mat. Who could open that one? You need MATLAB, that's right. And then I said, the people who stole it from me got a surprise. What was the surprise? Already CSV, huh?
Oh, okay, nice. So stealing what?
The stealing works. It's called competitive advantage. Now, I read a very interesting book called Data Science for Business Solutions. Data Science for Business, actually. And one of the key questions was, what's the competitive advantage you have? What's the data you have? And you got it first. So what did you do with the competitive advantage? Did you understand the data set? What was the why? They said the demons, who else? The different types of the categories of noise. Yes. Or imperfections, distortions. What else? Any other idea? No? Both of you are right. So then, you got the competitive advantage. What is DMOS? Demos. So the quality of the image. But did you have time to look at it and understand what is it, how it's calculated? The average of opinions, but you didn't see the methodology. Okay. Who else figured out what's DMOS? But what's it? How they calculate it? Almost, but no. Anyone else? Distortion level, okay, that's getting there. Someone else? No? So there is a paper of these people because this methodology is quite specific. It's not like I just randomly we will select the scores. Just 1 second, please. I am trying to explain and get distracted. Sorry. This is discussion time. So there's a specific methodology. They show to a subset of people an image, and everybody, and this image has a distortion. And then they ask the people, okay, for this image from 1 to 5, or 0 to 100, what's the quality of this image? And the answer is 20, and then 40, and then 25. The DMOS is the average of these opinions, because quality is subjective. What I see as good quality, other people can see it as low quality. So then you have the average, which is then with the D might mean distortion, the M is mean, the O is objective, and the S is a score, maybe. I am just inventing this. Then you have the deviation of this, but you also have the categories. So you could create a model to classify the specific noise, or to classify the score in the end. In the beginning of time, when everything started and they tried to calculate the score for image distortions, they needed to first create a model to classify what kind of distortion it is, and then, given the distortion, they calculate the score. In the present, that's not needed anymore. You can calculate both at the same time. So both of them are wise. Okay? Was it expensive to get the data? It was, no? It took us, for some, 25 minutes, for some, couldn't even finish. Okay? So now I need everybody to have the data, or at least as an example. We won't need it. But if you could get it from USB or something like that, it's gonna be good for Okay, so the next step. Next step is to prepare the data. So we need to be sure that we can open the files. We need to make sure that the data is clean. We need to understand the data. What is the distributions? We have outliers. We have missing values. And convert the data to a tabular format, which I already did for some of you. And for some, no, I didn't. The MAT contains the tabular data of the EMOS. So, everybody agree here, or yes?
How do you do that?
To do what?
Making the tablet form.
So this is a specific comment for example, the image. The image is actually a stream. So you need to turn this stream into a matrix of pixels, intensity, it's called. The pixel intensity comes from, you will tell me then when you do it, but this is what you need to do. Turn the image into a matrix. And also it refers, sometimes we have different kind of databases. Some databases are relational databases. We also have non-relational. So you have JSON and these kind of objects which are semi-structured. That's what you need to take those and also turn them into tabular data. So that's another step. But that's why it's very broad, because it's not specific to the data type, but it's something you need to do. And sometimes it's easy, sometimes it's not. So next activity, today is going to be super busy. So this is what I want you to do. I want you to write a Python function that receives a string. That string can be a URL or a local path. And I want you to return a NumPy array. Who knows what's NumPy? Okay. A NumPy array with containing the image. You need to turn it into tabular, and that's the first activity. For the ones that are faster, there's an optional assignment. You need to create a function that takes an image, NumPy array, and returns the image in black and in grayscale. I'm sorry, grayscale. 2 activities, and you have 30 minutes. For this one, I'm gonna stop at 15 minutes, and I'm gonna start writing the solution. So the people that can follow up can at least go with me. So you have 15 minutes to do it by yourself, and then I start typing the solution. Okay? Good. Go. What's PyPy? It's a repository with all the Python packages. Yes.
So, who has solved it already? There? Good. who has it now? Has solved the problem? Just them? Who's about to have to solve the problem? You, okay. So maybe should I start solving the problem with you? Cool. So, okay, let's stop a little bit. When I was talking, I saw your first problem. You didn't bring Python, which is fine. And then some of you were looking at Python online and failed. And some of you solved it, which is quite good. So let's solve the first problem. How to run Python online. Okay, so there is actually a solution from Google. It's called Google Collaboratory. You just need to go to Google Collaboratory. Yes? The first result, that's the one. Got it? Cool. So this is quite cool because first, it's free. Secondly, do you know what's a GPU? Who knows what's a GPU? Graphical processing unit, right? So that speeds up training of machine learning. They have it for free too. So let's click it. I think you need to log in with a Google account. In this case, they already have it. So you can click any of these. And then you can create a new Python 3 notebook. So another cool thing about this thing is it already contains Anaconda, I think. Who's here now? I need you to keep up. Come on. Log in.
You have an account of Python, so you can just use it and use it.
Yeah, you can use it. This is much easier. Yeah. So another advantage of this is it's a virtual environment. So whatever I run, if everybody opens the lab, you're going to be able to run it too. And with local environments, you might not be able to run it. Okay. Who's missing? Do I need to wait? Any question? Yes? No. Let's just get up to this point. Yeah. Up to this point, everybody is here now? Great. Sometimes they
Okay. So here. So what do we need to do? Open the image. We need to create a function. Okay? How do we create a function in Python? Def, right? How can we name the function? Load image. Sounds fine? What's the argument? Path? Or let's say URI, okay? And then in Python 3, you can do cool stuff like this is a string or str, and it returns. What did we say it returns? NumPy array. Right? And then let's say what's gonna happen if I play it? It's gonna fail. Why?
Because it doesn't call the object.
I need to load NumPy first. Okay, let's do that. Yes. So I can say code, and I will port just like this. Sounds fine? SNP? Okay. No, I prefer NumPy. Sorry. Then it will run, do you think? Okay. So let's call it. It worked. Okay. This is called a prototype. So we define the signature and what it returns. So we have our first function. Now we need to fill it with the right content. So their request was, I need to be able to load it from local and from a URI. And I said you can use any Python package. Any idea of a Python package that can do this? Pillow, that's a good one. What other one? OpenCV, okay. By what? That's also one. So you get very good examples, and all of them will do the job. Pillow will have the problem that you cannot open it from the URI because it's only local. OpenCV is super heavy, so you are solving a problem with a machine gun, and the other ones are also a problem. So there's one that is very easy to use, that is called Open Image.io, I think. It worked. So I can just, but I don't know how it works. What do I do? Let's Google, yes. What the documentation says is image.io and read. Perfect. Someone said that I heard. So I'm just gonna copy paste. That's the way to go. And instead of astronaut, what should I give it to it? URI. Now this one is gonna fail. Why? Some path doesn't exist. Great. We're on the right track. So let's try an example. And the URI of or URL of the image I gave you was this one. Good. So just copy. Boom. 2 lines of code. Right. So
So you loaded the image,
yeah, this is the image.
and then consider the image into an array of that's
Pixel intensity. And that's NumPy. So this is weird, no? How many dimensions do you think this has?
3.
3. Why? RGB. Red, green, yeah. Okay. You might have 4. RGBA or C, sorry. So how can I print this? I think the function is parameter is ending. It worked. Okay, yeah, great. And if I want to see the size of the image, what can I do? No, that's much easier than that. If you have a matrix, the shape is the dimensions of the matrix. Yes. Or size. No, shape. So you will have width, height, and number of channels. Good.
Width, height, and number of
Channels. So another question I have for you. What is the range of the pixel intensity? 0 to 225, 255, or 1 to 256, right? And if it's grayscale, it can be from 0 to 1. Any question up to here? Because things are gonna get extremely complicated, exponentially complicated from now on. No questions? So who could solve the second problem to turn it into grayscale? You. Tell me, how did you do it? You used the library, perfect. That was our right answer. There is something much easier. Do you know how to turn our RGB into how? You take the average of what? RGB. That's right. So if I am very rusty, so let me see if I can do it here. So what do you think is the axis of the channels? Because I don't know, I need help. So before, if I do, let's have a cell here, image that shape. That's the shape. The two? Let's see. How can I prove, how can I know if the shape is the width and height, no? Well, first, if it runs. Okay. Second, if the shape is, voila. Okay. So, a matrix of 3 dimensions, we have R, B, and G. And we are just taking the average. So now I have another question. What happens if I want to show the image? What do? I look for another library, yeah? Okay, let's do that. Huh? So this library just plots stuff. You can plot anything, even images. And I need to say first the color one. Anyone has an idea of how to plot this? I think it's not image, it's I'm show. So I'm read, which is image read. I'm show, and if you want to write it, I'm write. So quite easy. Ooh, I need to run it again. Yes, success. And again. Oops, what happened?
Image gray.
Image gray, great. Ooh. Now what? So we need to tell matplotlib that the C map is equal to. Sorry, this is not my computer. Gray, maybe? Let's try that. Ah, any question? So we created a function that receives a parameter, a path, or a URL or URI, and return the matrix with NumPy containing the pixel intensity. That sounds so fancy. And then we plot it, and it seems that it's working. Any question up to here? Don't be shy.
What if we use other picture than this piece?
Okay, let's use another one. You tell me. He's trying to prove that this is not true. What's nice? Dogs, pandas, airplanes,
Yes.
cats. Cats. No, I'm curious. Those are cats.
أنا ما أعرف I have actually so my experience also mostly about software products, project management, product management. So I'm getting out to machine learning to business. Yes. So Ricardo, I want to take the approach as possible to get the connection. I believe this connection is key. And I want to know more about you. Are you working? It's like experience. My connection. It's not anyway, I will not send you jobs. It will be a serious. So, what do you mention? Another 20 minutes, I think.
Okay, let's just wrap this up. I think they will come back. So let's finish this. Yes. Um, so we were able to load the image, show it, turn it into black and white. Um, so now we need to calculate the score, right? Which is modeling. I will just show you because it's very important. We need to upload the image. So it is just advising that after the session finishes, it's going to be erased. And then the cat is here. So that means the image is already in the local of the virtual machine. So we can just say, remove all of this. And say, what's the name? Cute cat. And it should work the same way. Okay? Work. Now you have it. So the function is actually doing both things. It is loading from a URL, from internet, and it's also loading from local. This is very convenient when you're working with machine learning because sometimes you have the data sets in your computer, sometimes you have it on internet, and this way you don't need to distinguish between them. So things are gonna get complicated now. So now it's time for modeling. Given for time reasons, we are not going to be able to see evaluation and deployment. I still have the material. I will share with you so you can see it later. But to finish this presentation, let's see modeling, which is the most important part up to now. So one big advice I give you is never start complex, because you need to gain the trust of the stakeholders. Once you have their trust, once you see it's working, you can iterate the model to something more complex. And I mean complex, we need to define complex, but yeah. So, in my personal GitHub, I have several notebooks with some of my research. We're going to use this. Brisk was invented in 2012, 2011. It was one of the first models that you didn't require to distinguish the distortion type or the noise in order to calculate the score. So you just give the image, it analyzes and returns the score. It's quite simple. So we will open, this time let's do it together. We will open the notebook and we will make it work. We will modify it so it works in Google Colab. And let's see how it goes from there. So, Yeah, I think there is no internet, but I think you can follow me maybe. Okay. So the process to open a notebook that is already existing in GitHub is open notebook. You can go to GitHub and say the username or the account in GitHub. That's me. And then here you have all the repositories. This one is one of the advanced models, but you can also open the not that advanced, which is Brisk. This one. Make sense? So here you can see two libraries. One of them you already mentioned is OpenCV, right? The other one is libsvm. Do you know what's that? Any idea? SVM, have you heard about it?
SVM.
Support vector machine. And lib with its libraries. So if I run, so in Python, Google, not in Google Colab, but in Notebook, Jupyter Notebook, you can run commands from a cell. So let's install these things.
Which folder is it from? Yeah, which repository?
You have internet. That's cool. It's Open Notebook, then GitHub, then my name. And then repository is notebooks. And the name is Brisk. Sorry?
Is there a reason why we have converted the images to grayscale?
So according to the theory, most of the noises you can detect with grayscale. So there's no point in having more data than you should. But there's also achievement in the advancement, they turn it into grayscale because given that frequencies do not affect the noise. So, okay, it's here, it's loading, and you can run the first cell. And this is one of the examples. A good example for the deployment part is I usually don't use OpenCV because it's very heavy. And it has a lot of stuff you don't need. And when you try to deploy, the images that you create in order to put it into production are too big. And it makes super complicated everything. But there's another point that in order to replicate Brisk, you need the interpolation that is coded in OpenCV in a specific version. So if we don't use it, it's not gonna work. It's fun. So first,
What is the difference between SVM and the other SVM, which is cyclic?
Very good question. So this libsvm, I wrote it because I created this package because it comes from it's called libsvm. This is the source, and sklearn used this code to create theirs, but then all the code, all the legacy models cannot be loaded with this scalar. So you need to use libsvm to load legacy models. And this model we're going to use was created using libsvm without that scalar. It's a different format. So that's why we need to replicate it. So first problem, no model named libsvm. So what do you think could happen? I installed it, and it was successful. Internet's back. Import SVM is here. So the reason is we installed it, but this is still not in the path. So let's restore this. Restart runtime. Yes. So runtime, restart runtime. Okay. So we restarted the kernel and it loads the path again. So the library is available. So now we can load it. Then there is a lot of text here. But a summary is image quality depends on observers. So there are several methodologies. There are mainly two branches, is reference and referenceless or blind. Reference means it requires the good quality one and the bad quality one to calculate the score. In real life, that doesn't happen. And blind means you just give the bad quality one and it tries to calculate the score. So here is the methodology. And these functions, so these functions are the Python version of the mathematical ones. Okay? So it basically it stands for image, and I and J, lowercase, it's the coordinates of the image. So you can see the image and you can have coordinates. And then mu, what do you think it's that?
Error.
The mu, the standard.
The mean, yes, the mean. But the standard deviation is the sigma. And the C is a constant. Why do we need a constant? Yes. If sigma is 0, we need at least something below, big enough, so it doesn't explode. Actually, it's called explode. The number can explode and then overflow. So this is how we calculate the mean, or mu. It's just the addition of all the i's times a weight. How do we calculate the weight? Well, the weight is a Gaussian kernel. Have you heard about Mr. Gauss? Or what's the name? The Gaussian distribution. Or normal distribution. That's it. It's just a bell.
I of ING is luminance, the M for
Yes. Is I of I comma j is the pixel intensity for the coordinate I and j. And then the mu is defined as this. Okay.
and sigma is
And sigma is the standard deviation of the image. First, we calculate the mean, and it's here. Convolutions? Anyone? I know him, but who else? Do you know what's a convolution? It's a mathematical operation. So in order to get the local mean, you need to compose the image using a kernel. And the kernel is the Gaussian kernel. So basically, what it's trying to do is, let's say, coordinate at 10, 10 of the image. And you have the kernel, which is a normal distribution. So you will multiply the kernel over all the pixels of the image, add it, and that's the intensity of that one. So it's like a matrix multiplication. And then you have the deviation. The deviation, normally the standard deviation, how do we calculate standard deviation? It's each value minus the mean square root over yes. So here is something similar too. So you have every pixel minus the local mean and again by the kernel. So it's similar but not the same. Okay. And then these are the features. So in the beginning we got the image. Now we will have something called MSN coefficient. And in the end the formula is every pixel minus the local mean over the standard deviation. Does that ring a bell? You do the exact same thing for other kind of stuff. It's called standardization or something like that, normalization. So we are normalizing the pixels. Easy. Okay. This got complex. Normally when you have a distribution and you normalize it, why do you normalize it? Do you remember the statistics class? Let's go back a couple of years. Yes. So you have a distribution, you know it's normal. If you standardize, we used to have some tables saying, okay, if we have that the sigma is then the probability is that. So you can go back and you can measure the probabilities. The accumulated and the discrete. So we are doing the same thing. We normalized. So now we know that the distribution behaves like that. Complex. I don't even know what is that.
What is the acronym of MSCN?
Sorry?
What is the acronym of MSCN? MSCN
Those are what it stands for?
Yeah, mean square.
Is mean squared coefficient. Wait a second, it's up here. I did this long time ago. Don't be so tough with me. Mean square. No. Yeah, mean subtracted contrast normalized. Yeah, that's hard to remember. So, okay, back. So in the end, let's forget about the math. Depending on the distribution is the type of distortion we have. So if we have a bell or if it's biased, these differences show us signs of distortions. So that's the idea. So in the end, you need to calculate the coefficients and then calculate what's all the parameters of these functions
and the parameters are the actual features for the machine learning model.
So distortion, you mean it's going to be like outliers or higher values?
No, distortion, it's another way to say what type of noise you have in the image. It can be pixelation, Gaussian blur, and salt pepper noise, what type of noise? That's called distortion.
I mean that would affect the normal distribution. Right?
Yes, yes. The type of distortion can turn the normal into a biased distribution, skewed, can be skewed, or can be a little bit skewed, and then what's the other one? The kurtosis can also affect the kurtosis. So let's go, let's just run and verify that works. So the important part here is not the methodology, is how did we get up to this point? So we analyzed the business problem, we came to the hypothesis, and then we were like, we're not gonna build this from scratch. Let's look at the literature and see what others have done. We found this method from 2012. It's not that complex. I mean, as long as you can code the math, you're gonna have a solution. And you don't require like a lot of expertise in machine learning. That's it. And then we found another method that is also in that slide that is more complex. It requires deep neural networks. It requires more data. And we decided to go with Breeze because we can create a prototype quite fast. We don't need to wait to get more data or to analyze it, or you get something fast. You get a prototype, you can show it, manage expectations, and then iterate from there. So this is what we're trying to do. We're trying to show them that it works. So we calculate everything I just said before, but this is gonna fail. Oh, here. Okay, I think this is, now it's easier to show. So in the end, you have the coefficients, and this is the distribution. Almost normal, right? And if it's a good quality image, let's say it's gonna have this shape. But if it's a bad quality image, let's say the distribution is gonna be biased to this side or biased to this side, and depending on the bias, it's gonna be the type of distortion. I mean, the concept is simple. Calculating it, maybe not much. So once you have the distributions, you want, let's say, calculate the, in order to define a normal distribution, you need some parameters. Which parameters? Mu and sigma. Scale and shape, right? Scale and shape. Here is the same case. We are trying to calculate the parameters of these distributions, and these parameters are going to be our features. So let's say we have this function, and the mean is going to be 2.5, and the sigma is going to be 1. Those are all features that we are going to input into the machine learning model, and it's going to output the score. A little bit more complex than that, but almost. So here we're gonna face the first problem. We have local files that we are trying to load here. Is it gonna work? No. because it's in the cloud. So it's not gonna run. When we run it, we just define the functions. Now that we run it, it fails. I don't find this file. So in real life, you're gonna face the same thing. You're trying to replicate others' work, and it's not gonna work. What do we do now?
Copy the code to the variable condition.
It's not the code. The problem is not the code.
Now what we know happens.
Huh?
The path is that.
The path is not the problem. You need the file. So let's steal it. It's in my repository. So here's one, and here's the other one. What do I need to do? I can't download it, no? Ah, look at this. This is the parameters of the SVR. So I just go here, save as, that. And now I need also the other one, right? So another question. Oh, it just downloaded. In data science or in math or in anything, you need, when you create a machine learning model, you need to split the model into train, validation, and test. The question is, normally we standardize the data set. What happens with the following data sets? Do you standardize again? No, what do you do? Huh?
After standardizing the data set, then we need to split for training and testing.
Yes, but almost. We cannot, so for example, standardize, we can standardize, let's say, the data set minus the mean over the standard deviation, right? Mean and standard deviation are parameters. So we cannot recalculate that in the following data sets. We need to use these parameters to standardize the following ones. So this is the same thing. So the normalized.pickle contains the mean and the standard deviation for all the features. So we can replicate the standardization for the validation and test. So I already downloaded.
What is that pickle file?
Excuse me?
That pickle.
.pickle is
It's a serialization and
that's serialization file for Python. So you can serialize Python objects. So let's say you have an object in Python, whatever object, you serialize it, and you can load it in another computer, and it's multi-platform.
It's like a protocol buffer.
Like a protocol buffer. It's getting complex.
It's like a file. It's a storage file.
It's a storage file, yes. But he's right. It has a certain protocol, so all the computers can read it with Python. But let's check. So what do we need to do? We need to upload the model and the normalization parameters, right? So this is model. Okay. This is cool. Right? So now it should run, right? So it's running. Something important is look at the time it takes to run. 13 milliseconds. That's extremely fast. So the impact of the complexity of this model is very small. It runs fast. So it means if we take this same code and it's well written, we can put it into production and it's not going to affect anything right there. So let's say if this would take 3 seconds, what do you think? Do you think someone is going to wait 3 seconds? Oh, now it finished. So this is something we need to consider. Okay, so the other question is, does it work? It seems like a good quality image, and it says the lower the better. So 4 is good, 100 is bad. So it's like good quality image. Now let's test it. I'm gonna go quite quick to evaluation. Oops, I'm going back. So the next step is evaluation. So in this step, you need to make sure that the metrics you're using are the proper ones for business and for your model. As we don't have any more time, in order to test the performance of image quality assessment, you use something called correlation, Pearson correlation and Spearman's correlation. Again, a statistics class. What's Pearson's correlation? What's the range? 0 to 1, almost. Yes, negative 1 to 1.
She said that she did it the first one, but in low voice.
Minus 1 to 1?
Yes.
Sorry. First. So what does minus 1 mean? Negative correlation, but what does that mean? No, it does correlate.
Something increase, the other thing decrease.
Yes. So we have one distribution that while this one is increasing, the other one decreases. So if the weather, no, that's a bad example. Supply and demand, no, those are also that's a bad example. If so, you're saying that if supply goes up, demand goes down. Okay, let's use that example because I can't. Huh? That's good. Okay. The higher the weather, the lower the people goes out to streets or to a place. That's negative correlation. And then plus 1. If something goes up, the other thing goes up. So for example, in our case, we're saying if the quality of our images increases, the leads are gonna increase. Positive correlation. Why are we using this metric to measure quality or to measure the performance of our algorithm? So in our case, we're saying what the people said is correlated to what the model is outputting. So if the people says, I think the quality of this image is 1, 1, 1, 1, 1, and then the algorithm says 8, put dot 8. Seems similar. But then the next picture, people says 1, and the algorithm says 0. That's bad, no? And then with correlation, if the correlation is high, means the algorithm behaves as people. According to what I've heard, you already know a little bit of this. So, pro tips. In the end, what we created right now is not the model. The model in the end is what the engineers implement. So if our model is perfect and then the engineers mess it up, nothing good is going to happen. Then, for that, in order for me to have the same thing as the engineers, we can use Docker. Who has heard about Docker? Nice, okay.
He's going to be doing a workshop on Docker next month.
Ah, you're gonna give Docker workshop. Nice.
I'm sitting beside a celebrity.
Yes.
So Docker is just creates, and he might correct me, it's a virtual environment. But the interesting thing about this is it creates very small containers that is like it just encapsulates the OS, all the dependencies, and everything you need is there. So doesn't matter which computer runs this stuff, it's gonna run the same way in every computer. That's the advantage. And a very good practice is you can create a Docker container for every version of the model. So you can roll back. It's very easy just to switch. I'm going to get into more complex stuff, but it's very easy to switch pods. You say this is not working, then switch it with the one that was working. That's it. It's going to take seconds just to switch it. And imagine if you need to roll back a model without this kind of tools, then it's like, okay, I multiplied by 5. Now I think I multiplied by 3, so let's roll back to 3, and then take everything into production. It's going to be super complex. So with this, it's super simple. Another thing, pro tip, version everything. Data sets, models, code, dependencies, everything. The slightest change in dependencies, code, even in data set, is going to change everything. And if you don't keep track of it, you're not gonna even notice that it happens. I have a story here. So back in Mexico, I was working on before in my time to measure electricity. We used to have electromechanical meters, right? It was like an electromechanical meter with some dials and like a clock, like 1, 2, 3. So I created an algorithm to extract the dials and measure the numbers, right? I was using OpenCV. And at that time, it was even harder to install. And I used to have, I even remember, the 2.4.3. And then, by mistake, because I am a very nervous person, I always try to have everything upgraded. So I upgrade my system, and I've got a very big presentation next day with my thesis director. I changed it from 2.4.3 to 2.4.4, which is a minor change. Minor. But I didn't realize because, I mean, at that point of time, what is a dependency and what is a version? So next day, I was showing my super cool tool that I tested like 10 minutes before or something like that. It was working. I upgraded. I didn't notice. Everything was broken. Everything, like everything. Because the algorithm I was using used to have a patent. So they told OpenCV, you need to modify the algorithm. They modified it, they messed it up. So it was not working anymore. So that's why it's a pro tip. And in data sets, it's even worse.
So Docker would help for that too?
Huh?
Docker would help for that too, so dependencies could be.
Docker will help for dependencies, code, and models. But data sets, it won't because it's a good practice not to have the data set in the Docker. And finally, another pro tip is automate everything. Pre-process, post-process, everything. Right now, I am delivering some code to some people, and then they're asking, where is the documentation of the code? Why the code doesn't have comments? That's bad. Like, no, it's actually the opposite.
Yes, yeah.
The code shouldn't have comments. The code should be documented in the code. Because when you modify the code, the results are affected. If you modify a comment, nothing happens. So, next time someone tells you you need to add comments to your code, tell them, no. The code is self-explanatory.
Really?
Well,
When
should
I
be
did
like
that,
that.
my professor minus marks. He said should have used comments. And since it's a good practice.
To use comments?
C++.
So, tell him what you learned today. That's Not true. And this book who says the opposite.
Okay, glad I got that.
Yeah, there are several books, not just me. And I think that's pretty much it. There was another. Well, the way I found to work better is the data science, the components, which means you shouldn't be implementing how you fit your model. That's someone else's work. You just have to assume you're going to receive X, Y, and Z. You process it, and the only thing that is going to stay is the model and the interface that communicates with the rest. If we can load another image. How can we find a bad quality image? Let's go to bad quality.
That's right, but we can go to Google and
I think Google is going to be better.
yeah, Google and then when we go for the search.
I think I don't have internet.
No.
You got the internet, but you're through a hotspot, so it's on 4G right now. Oh, it's back. You can probably connect back to the assembly. If you want to switch back to the other Wi-Fi, it'll work as assembly. Assembly. Stay connected. Come back. Oh, yeah.
So, correlation. Very
More expensive has higher quality?
higher quality pictures.
Because people who buy expensive stuff need to see the quality.
Yeah, and that's true. So in the end, if I'm gonna buy a 10 million dirhams house, I expect nice pictures, nice description, nice price. Because if you see low quality pictures, what do you think? I cannot trust these agents first. They're not professional, right? So engagement.
But that doesn't work picture.
Now I am wondering if it's property finder or if it's the internet.
You're on 4G.
It's okay.
So you were running on your notebooks on this, so that showed how fast.
I don't think.
The solution
No,
will be
but
out.
just say low quality image.
We can change the quality of the image by painters to make it lower.
What? Okay. But I don't have internet, so the collab is not gonna work either.
We can trust them.
Check works. I've checked the best image works.
It works? Can we trust him? Yeah!
We need to share the URL. You have to the assembly network comes from the unified network. So the unified network has problems. The assembly one that also. I think it might be better off with the second one. Yeah.
That was the one I was using.
It's slow, but it's connecting.
Slow, but it works.
It's contacting the host. It's just like this. You might want to change that up. It's extreme. Well, it's
Internet for everyone. Well, Not even mine. I think no internet. Yeah. Wait. Mine worked.
Quick.
Okay. So let's describe the quality of this picture. What's the lighting? Is it good, the lighting? Is it obscure? Is it too bright? It's okay, no?
Why do they have light on when it's already morning?
Sorry?
Why do they have the lights on when it's already morning?
If you see this picture, they even use flash. So if you just take the picture with those lights, you get them. It is still obscure. These guys use professional stuff. So these guys are pros. It's a nice picture. It has the content we desire, which is a property. You can see the environment. It's not very pixelated. It is pixelated because it's compressed. The original image, I think, is going to be much better. So if we go here, copy image address, and paste it here. Good. Now you see where we are going. You notice the difference, right?
Yes.
Nice veil, ugly veil. Great, it's working. I'm going to tell you why. This is not the original image. This is a compressed image. That's why you saw that the bell changed to a peak. So the algorithm detected that it's compressed, and it showed that the score is 50, which is high, but it's not that bad. I mean, you mentioned the other challenge we have. What is bad and what is good? 50 might be average, we can pass it.
The other one was single digits, right?
It was 4, right?
4 is great. 4 is very good. It's almost perfect. So let's see the counterpart. So we said correlation. Correlation is expensive, good images. Now cheap, bad images, right? In the UAE, that doesn't happen.
Second one.
Second one, this one, huh? Ah, beautiful.
Beautiful.
Ah,
The apple just
so bad. Again, you're seeing the compression. That's why it's like that. So there's correlation. The image was worse. But I think the score didn't show what we wanted to see, which was a terrible picture, right? Because we are also taking into account the lighting, low quality lighting, the context. Why do I want to see the corner? We are actually measuring the pixel integrity, not the context, nor the lighting. So we saw, and maybe I'm speaking too much now, but more problems. We need an algorithm that measures the lighting of the picture. We need an algorithm that detects that is the context, the image, the content of the image is proper. So So the final score is not going to be this. The final score is going to be the average or the weighted average of the lighting model, context model, pixel integrity model, etc. So that's it. Thank you very much for coming. The type of image.
Okay, thank you everyone for coming, and thank you to Ricardo again. I think we got a real good insight into some stuff that doesn't get discussed in Coursera or when you're just looking at theoretical data science. He's used it in the real life scenarios, which is promising. Okay, we're going to be announcing next month's calendar. Coincidentally, this is probably one of the rare times there are actually 5 Saturdays in February, which only happens in leap year. Only can happen in leap year. But we'll be announcing the calendar. There'll be one DevOps workshop. We'll have next week. We'll be building. We'll be doing a capacitive touch workshop. So we'll show how you can use any object. You can make a flower, pedal piano, or something like that. The week after that will be your workshop on DevOps. Then after that, we'll be doing 2 IoT workshops back to back. One will be a home automation with Tasmota. So we'll be working with the Node MCU boards for that. And then the week after that, we're going to be doing an Etisalat workshop. So every 2 months, we do a workshop with Etisalat Future Now. That'll be, of course, IoT based. So working with their platform, they're going to give us access to that. And then the week after that is an exciting one. We've got the Raspberry Pi birthday coming up. So that's a global event. So we will be building a game console for that. So that's on 29th. So that is the of February. Yeah, this is all for February. Everything is online. You signed up also. We'll add you onto the onto the mailing list. You can go to YouTube. The assembly channel. Just search for the assembly. It's there with us. We'll share the link also on the forum.